Hey there, welcome to this lecture. Now we're going to talk about interfaces, which is a crucial concept in Java. It's not difficult to understand, but it's very important and it's used throughout the Java language, and you're going to find yourself using interfaces all the time. So let's get started. So in the previous lesson, we left off where I was discussing about variable types and how variable types have access to methods that are defined in their type specification. So animal1 was a variable of type animal. It will only have access to the methods that are defined in the animal class. Similarly, the bird has access to those methods that are defined in the bird class. But if we take a look at the bird class, you'll notice that it's not just the class itself, it also has the animal component. It's extending from the animal class because it is, in fact, an animal. It's just a more specific kind of animal. So it inherits all of the functionality that the animal has, and then it adds on to that functionality the ability to be able to fly because it is a bird. So the bird specification is not just what you see in this class, it's a composite of the class that it extends. Alright, so now it's time to talk about interfaces and abstract classes. These are both approaches to better organize our Java code. And many object-oriented languages provide this way of structuring our code. But before I talk about interfaces and abstract classes, let me pose a problem to you so that you can see where the abstract class or an interface is applicable. So let's say we need to create two more types of animals, and they're both going to be birds. Let's say we need a chicken. So I'm going to right click here and go to new class, chicken. And a chicken, I Googled this, a chicken is a bird. So I'm going to make it extend the bird class. And we have to implement the constructor here. I'll just leave it as default. And I'll create another type of bird. Go to new class, and that bird is going to be a sparrow. And that will also extend the bird, right? And we follow the Eclipse suggestion, we implement the constructor. All right, so now we have both chicken and sparrow both extending from the bird class, right? So the bird is the parent and these two are the child classes. And these two child classes are inheriting behavior from the bird. But do you see a problem here? If we take a look at bird, it has a method in here called fly, right? Now a sparrow can fly. It makes sense for the sparrow to be inheriting the fly method. But for a chicken, the fly doesn't quite make sense. I've never seen a flying chicken before. So what do you think is the solution here? Now, if you didn't know what an abstract class was or an interface was, a way to get around this is in the chicken class, we would define the method called fly. And we can print out not able to fly. So that the users of this class, the users that create a chicken object, when they invoke the fly behavior, this method is actually going to be the one that gets invoked, not the one that's defined in bird. Now you may not be familiar with this concept. So what we're doing here is we're defining a specific method for chicken called fly, and in it we are saying not able to fly. This is actually called overriding. Overriding basically means that we are replacing a method that we are inheriting, right? So basically the method that's defined in bird is being inherited into chicken, and we are redefining that method more specific to chicken in the chicken class. So let me show you what will happen if we actually create a chicken object and call fly on it. So back in the zoo class, I'll create another object in here. I'll call it chick1 is equal to new chicken. And we obviously have to give it some values here. And now we have an instance variable of type chicken. It will have visibility to the methods that are in chicken. So what are the methods? What methods does the chicken class have? if we take a look at this, it has all of the methods that are defined in bird, and then since bird is extending from animal, chicken has the visibility to all of those. It basically inherits all of those methods. But one thing special about a chicken is that it flies in a different way. Now let me print out what will happen here. So when I invoke the fly behavior on this instance variable of type chicken, what do you think is going to get printed? Let me run this and see what happens. Notice that it's saying not able to fly. That's because we have overridden the definition of the method fly so that it's more specific to a chicken. Now, if I go back in the chicken class and I comment this out and go back in the zoo class, notice that I still have visibility to the fly behavior. And the reason for that is because, of course, we are inheriting the fly method that was defined in bird. So now the chicken, instead of not being able to fly, it will be able to fly. So let me run this method here and notice that it's able to fly. Right, so that is called method overriding. All right, that's one approach to prevent other developers that are going to be using this code. It's one way to indicate to them that, hey, it's not a good idea to invoke the fly method on on an object of type chicken. The sparrow will just inherit the fly behavior as is because the sparrow is able to fly. But in the chicken class, we are overriding the fly behavior that is defined in bird. Now this is one way of solving, well, it's not really solving the problem, but it's at least bringing this problem up to the user that uses this class. A better way to fix this is to remove the flying behavior from bird. If we go into the bird class, let's just get rid of this behavior, because in reality there's plenty of birds out there that don't fly. So what we need to do now is we need to create an interface. An interface is basically a contract, and any class that implements that interface, it becomes compulsory for that class to implement the methods that are defined in that interface. Let me show you what I mean. Let's create an interface. Go to new, and we're going to call this interface flyable. All right, we are naming it after the functionality that we are trying to abstract away. That's what interfaces should be named after. They should be named after the functionality that we are trying to abstract away. So let's finish that. And now I'll define a method called fly in here. And that's it, we're done. We actually don't give a body to this method. An interface has methods that do not have bodies. And these methods are called abstract methods. All right? An interface only has abstract methods. And an abstract method is exactly what it sounds like. It's an abstraction. It's an abstraction of the idea, the general idea of something being able to fly. Now let me show you how we can apply this interface. In the bird class, I've removed the fly behavior, so chicken is happy. I don't have to have this fly behavior in chicken anymore. But the sparrow is no longer able to fly. Luckily, we have the interface flyable defined, so now we can implement flyable. And now notice Eclipse is going to complain. If we hover our mouse over this, it's saying that the type sparrow must implement the inherited abstract method flyable.fly. Right? Notice what they're calling it. They're calling it an abstract method in the flyable interface called fly. Right? And it's saying that sparrow must implement that inherited method. So we have to implement that. You select this add unimplemented methods and notice that it has basically forced us to put something in this body. We're defining a body in here. You can get rid of this annotation for now. We'll get back to those later. So if I don't have this method, this class is not even going to be able to compile, right? the compiler is complaining that we must implement that method. So what I'll do is I'm going to just leave a simple print line statement in here saying sparrow flying high. All right, we can get rid of that. So back in the zoo class, we obviously don't have any visibility to any fly method anymore for the chicken. So again, what is an interface? It's a contract. Any class that implements that interface, the interface wants that class to promise that it will implement that method. Now, a key thing to remember is a class can only extend one other class, right? So it can only have one parent, and that makes sense, right? A sparrow can only be one thing, right? It's a bird. A bird can only be one thing. It's an animal. Yeah, a bird could be a mammal. It could be considered other things, but what is its primary breed? It's an animal. So that's its parent class, and it will only always ever have one parent class. And sparrow will also only ever have one parent class. Any class cannot have multiple parents, right? But it can have as many interfaces as it wants, right? The sparrow can implement flyable, it can implement eatable, it can implement many other kinds of interfaces without a problem. Right, so hopefully interfaces make sense, and if they don't worry. I wanted to introduce this concept to you at least of an abstract method, because we're going to be using that a lot more throughout the course. Alright, so I'm going to wrap this lesson up here. I think it's a good time to stop. In the next lesson, we'll talk about abstract classes.